Okay, this is a correction video for the ptvtat free response test. If you have a test that looks like this is your correction video. Okay, so here's our velocity time graph, and the biggest mistake I was seeing on this test just to begin with is that people were getting their position time graph and their velocity time graph confused. Okay, so I'm just going to make up some arbitrary numbers here. Here's our 0 meters per second, and there's no negative region to this, so there's no negative velocities. Everything is headed in a positive direction. So I'm just going to put some arbitrary numbers up here, 2, 4, 6, 8, let's say. Okay, so this would represent 2 meters per second toward the east. Let's say east is positive, okay? West is negative. This would be 4 meters per second east, because this is velocity, not position. Okay, so if I said exactly what location did A start from, you couldn't tell me because you can't tell on a velocity time graph. Okay, it's velocity that's on the y-axis, so don't get them confused. Okay, so here's what's going on. Let's say this is for drivers. Driver A is traveling 8 meters per second toward the east. And then a short time later, he's only traveling 6 meters per second, still toward the east. And then 4 meters per second toward the east, etc. So you can see that he is slowing down while he is driving east. A negative slope on a velocity time graph does not indicate a negative direction. If you're on the positive part of the graph, you're traveling in a positive direction. So don't get it confused with position time graph. Okay? Driver B and D both are speeding up in the positive direction. And then driver C is traveling 4 meters per second, still traveling 4 meters per second, still traveling 4 meters per second, so he has a constant velocity. Okay, so number 1, which object is maintaining a constant velocity? Okay, if you put B, D, or A, you were probably thinking of a position time graph, because if this were a position time graph, a constant slope is a constant velocity, because slope on a PT graph represents velocity. But slope on a VT graph, remember, represents acceleration. So if I talk about the slope on here, I can insert the word acceleration. Okay, so if you have a constant velocity, you have no acceleration, so I need something with no slope. No slope, no acceleration. And that would be C, traveling 4 meters per second at all times. Okay, number 2, which object is experiencing a constant positive acceleration? Okay, so everything is headed in the positive direction here, so in order for it to have a positive acceleration, it would have to be speeding up. Okay, you would either have to be going in a negative acceleration and slowing down, 2 negatives make a positive, but nothing is going in the negative direction, or you would have to go in a positive direction and be speeding up. So that is B and D, both positive direction and speeding up. Okay, 3, which object is not moving? If you put C, you're thinking of a position time graph. If this were a position time graph, this object would be at 4 meters, still at 4 meters, still at 4 meters. It's not a position time graph though. It is moving at 4 meters per second at all times. So which object is not moving? The answer would be none. They're all moving. Which object is changing direction? Okay, hopefully you put none, because whether this is a PT or a VT graph, it would still be the same answer. Okay, but on a VT graph, in order for you to have a negative velocity, it has to be down here. So in order for you to change direction, you have to cross the 0 line. You could go from a negative to a positive, or a positive to a negative, but you would have to cross the 0 line. Okay, which object has the greatest change in velocity? So that would be the one with the steepest slope. Okay, so if you look at A, it has the steepest slope. It covers from 8 down to 1. Okay, B covers from about 6 down to 0. So 8 minus 1 is steeper than 6 minus 0, right? So steepest slope, greatest change in velocity. So that would be A. Okay, sketch a position time graph with 3 lines to represent A, B, and C. Okay, so I'm moving this to a position time graph. So for A, I have a positive decreasing velocity, right? It's headed in the positive direction, but it's decreasing. Remember, slope here represents velocity on a PT graph. So if I have a positive decreasing velocity, I need to have a positive decreasing slope. Steep followed by shallow. Okay, for B, I have a positive increasing velocity. Not very fast, followed by steep, positive increasing slope. For C, I have a constant positive velocity or a constant positive slope. Okay, moving on to number 7. Sketch a position time graph for an object that is speeding up toward the east. So position time graph, speeding up toward the east. Definitely it's going to have a positive slope because it's going east, and it needs to have an increasing slope. So I don't care where you start because I didn't give you a certain place to start, but as long as the shape of your line is an increasing positive slope. Okay, number 8. Sketch a velocity time graph for an object that is moving in the negative direction and speeding up. Okay, I accepted a couple of different answers on here. What I was looking for, if it's headed in the negative direction, it definitely has to be on this portion of a velocity time graph, and it's speeding up. I was looking for something like this. That's what I was looking for. But since I didn't say it was speeding up at a constant rate, some of you were thinking of a position time graph, even though it's a velocity time graph, and you did something like that. And so that would be speeding up in the negative direction on a PT graph. But technically, since I didn't say speeding up at a constant rate, as time goes by, it's still increasing. Okay? And I also had like one kid do that, which would be wrong on a PT graph. But still, by definition, I didn't say at a constant rate, so it still works. So I okayed this because it's my fault, but I was really looking for this. Okay, sketch a velocity time graph for an object which is moving with a constant positive velocity. Constant positive. I gotta go to the positive side. Constant. Not increasing, not decreasing. It's a constant velocity. This is a VT graph. The most common wrong answer on here was this. Because if I had a PT graph, that shows a constant positive velocity. Slope here represents velocity, right? Constant positive slope, constant positive velocity. Okay, but this is what I'm looking for, a VT graph. Okay, sketch an acceleration time graph of somebody moving in the negative direction and slowing down. Two negatives make a positive acceleration. Should look like that. Okay, study hard for that retake. Watch the review scenarios, part 1, part 2, part 3. Watch the notes. Do the other test if you want to. Study hard.